So good morning everyone. Welcome back. My name is Arslan and you are watching Proper Tech Tutorial. So this is the part 30 of learning siemensnx from beginner to pro, and in this we'll be starting the detailed and descriptive part of the assembly constraint, that is basic assembly constraint part 1. Now I will show you the syllabus for your reference. That is, we'll be dealing with the following three constraints: touch, align and infer center axis. So I'll go to the NX environment, I'll create a new file and I'll just type the name as part 30. And after that, I will cancel this dialog box. I will go to the model, or I cannot go to the model. That depends upon you. I'll click on date and coordinate system. I'll click on apply and then I will click on OK. The coordinate system has been added 2 times because once I clicked apply, the second I clicked OK. So after clicking apply, either you have to click on OK or you directly click on OK. Now, adding the component. First, what we'll do is that I will add the component, which are the things which are touch, OK, align, OK, and infer center axis. OK. Align center axis or infer center axis, OK, it is the same. No problem. So what I will do is that I will add the fixed pen, I will select the object, absolute displayed part, I will click on apply, it will be in the XY domain, I will just click on apply and it is now yes, because I want it to be fixed. Next what I will do, add 4 M6 threaded bolts, and M6 threaded bolts will be added 4 times. I will add them 4 times. I will move them using the snap, and I will move them in this fashion. I will keep them over here. Okay, now it is much better. Okay, now I will click on apply. After that, I will click on cancel. So we have 4 M6 threaded bolts that are totally unconstrained and needs to be constrained either partially or completely. Let us do that. So first of all, what we'll do is that we'll just take one of the threaded bolts and we'll use the constraint that is touch and align. As you see, the touch and align. Okay, so that is in one single constraint type, that is this one, touch align, and it will have you the option of 3 things: touch, align and infer center axis. So all the 3 of them are clubbed into one. So touch means that if you want to touch this particular surface to this particular surface, then you will have to use the touch. And if you want to align the particular axis to another particular axis, you will have to use the option of align. So I'll just deselect that. I will take this, I will select this center axis, align, and I will select another center axis. Let us say I want to select the center axis of this hole, and you see that it got aligned as per the center axis of both the objects. I want to reverse it, I can reverse it, and I can also move it up and down, and you see that the constraint will be followed exactly. Now I will click on apply. After that, if I want to touch this particular surface and I do not want this linear translation motion to happen, I'll just show you the degrees of freedom this particular thing has, and you will see that it has the degree of freedom in the y-axis and the rotation about y-axis. I will also show you by moving that orientation. It can rotate in this manner, it will not rotate in this manner, it will not rotate in this manner, and it will not translate in either this axis or this axis, z or x axis. It will only translate in the y axis. So what now I have to do is that I need to restrict the motion of the y axis, that is the linear motion. I'll click on assembly constraints, I'll go to the touch align, I will click on the touch part, I will click on this surface, and I will click on this surface, and I'll click on apply. And now if I will see what is the degree of freedom remaining, it will only have the degree of freedom, that is the rotational degree of freedom about y axis. If I try to move it, you will see that it will only rotate in this fashion. Now I want to have this body that after getting fully tightened, the fixed part in the fixed pin, I want it to be like this face is already parallel to this. Let us make this face parallel to this face. So I will keep the assembly constraints. I will take the parallel and I will select this and I will select this. It will get parallel. So as of now, we are not studying parallel constraint. So we'll let it be like that. Coming to the touch, align, and infer center axis. Coming to the infer center axis constraint. What we'll do is that I will select this, I will select the center axis, I will select this center axis, and you see that it also has the same effect of the previous one. That is, previously it was align and now it is infer center or axis. So infer center axis is more accurate when dealing with something which is irregular shape, and it allows you to have the mean of the whole feature in the between, that is the center or the axis of that particular body, and it allows you to select the center line with much ease and much more accurately. For example, this is a circle, this is a threaded part. It can easily predict, you can easily do that with the help of a line. But in case it would have been certain like irregular shape, the infer center axis is very useful in that. The infer center axis, touch and align are the part of one single assembly constraint, that is touch align. So with this, we come to an end of our today's lecture, that is touch align and basic assembly constraint 1. And in the next video, we'll be starting with basic assembly constraint part 2, that is concentric, distance, and fixed constraint. So till the next time we meet, I would request you to please subscribe to our channel, hit the like button, and share your videos with your friends. And if, in case you find them useful, and let us meet again in the next video. Till the next time we meet, goodbye.